Find the vertical and horizontal asymptotes, the domain, x-intercepts, and y-intercepts. So, to find domain of rational functions, you first have to set the denominator equal to 0. So that's your first step. Your second step would be solve. And then once you solve it, once you have your x values, for example, let's say you get x equals 1 and 4, then your domain is all real numbers except x equals 1 and 4. So when you're finding the domain of rational functions, you always set the denominator equal to 0. You solve it. Whatever answers you get, you put them as excepts. So all real numbers except 1 and 4. Now, to find your vertical asymptotes of rational functions, you're going to get these answers here, and you're going to plug them in to f of x. Okay, and you should get one or two things. When you plug in each of these numbers into your function, and if you get number something over 0, it doesn't matter what number it is, it can be negative, it can be positive, but if you get number over 0, you have a vertical asymptote. Oops. Asymptote. Okay. If you plug in another number and you get 0 over 0, this is not a vertical asymptote. We call this a point discontinuity. Point discontinuity. In other words, an open hole in the graph, not an actual asymptote. To find horizontal asymptotes, we classify horizontal asymptotes to be derived in three ways. If the function is bottom heavy, for example, bottom heavy means that if you have x plus 2 over x squared plus 2x plus 1, bottom heavy means if your degree on the bottom, or if your power on the bottom, is bigger than the one on top. That's called bottom heavy. And anytime you have a bottom heavy graph, a bottom heavy function, your horizontal asymptotes are always going to be 0. Now if you have top heavy, for example, let's say I have this the other way around, x squared plus 2x plus 1 all over x plus 1. Notice that I'm top heavy because my power of 2 is greater than my power of imaginary 1 in the bottom. So top heavy is always going to be plus infinity or negative infinity, depending on the signs. For example, if this was negative in the front, then it would have been negative infinity. But if they were both positive, then it would have been positive infinity. And then there's one called the same degree. So I'm going to have to make this one up. So let's say that you're given a function, for example, like x squared minus 4 all over x squared minus 3. Well, to find the horizontal asymptote for this one, notice that they're the same, 2 and 2. They're both the same. So what do? We get the numbers in the front of the x's and we divide them. So my horizontal asymptote here is 1. Here's another example just to make sure that you get it. 2x squared minus 4x minus 9 all over 6 minus x minus x squared. Okay, so do I have the same degree top and bottom? I have a 2, that's my highest power. In the bottom, my highest power is also 2, so I'm going to get these two numbers. 2 divided by a negative 1, and that gives me negative 2. So that is my horizontal asymptote when I have same degree. X-intercepts, you set y equal to 0 and then you solve. That's all you got to do. and whatever answers you get are your x-intercepts. And for y-intercepts, it's the other way around. You set x equal to 0, and then you solve. Okay, so that's a brief introduction. Let me go ahead and help you out with the problems that you need help with. So let's go ahead and do domain first. So domain, set the denominator equal to 0, solve it, and then domain is all real numbers except the numbers you solved. So let's go ahead and start. So for domain, I'm going to set the bottom equal to 0. So x squared minus 4 is equal to 0. And then I'm going to go ahead and add 4. X squared is equal to 4. And then I'm going to go ahead and plug them in. So, I'm sorry, solve it. So it's going to be x is equal to the square root of 4, which is plus or minus 2. So my domain is all real numbers except x is equal to 2 or minus 2 and plus 2. And this is my domain. Okay, so now let's go ahead and find vertical asymptotes. Or let me just do VA. VA is easier to write. Vertical asymptotes. Okay, here's what I'm going to do. I'm going to plug in these two numbers into my original function, and let's see what I get. So let me go ahead and plug in the negative 2. If I plug in negative 2 into my function, then I'm going to get negative 2 plus x minus 6. Oops, no. Negative 2 plus a negative 2 minus 6. Negative 2 squared over 4. I'm sorry, minus 4. And then we get 4 minus 6 and minus 2 become a minus 8 all over 0. And this is negative 4 over 0. And this is number over 0. If I go back to my notes, number over 0 gives me vertical asymptote. So this is x equals 2, x equals negative 2 is a vertical asymptote. Let's try the other one. So let me go ahead and erase all this, okay? That way I don't have too much stuff on my screen. Let's go ahead and plug in the positive 2. So 2 squared plus 2 minus 6 all over 2 squared minus 4. So let's go ahead and figure it out. So it's going to be 4 plus 2 minus 6 all over 4 minus 4, and that's going to be 6 minus 6 all over 4 minus 4, and that is 0 over 0. And we said that 0 over 0 is a point discontinuity, not a vertical asymptote. So your only vertical asymptote for letter A is x is equal to negative 2. Now that's not always going to be the case, okay? You may have two vertical asymptotes. You may have no vertical asymptotes. They may both be point discontinuities. Now let's do horizontal asymptotes. So let's go back to our notes. Horizontal asymptotes. We first have to identify bottom heavy, top heavy, or same degree. So let's go ahead and see. This function is same degree. If you notice, 2 and 2, same degree. So it's going to be dividing the numbers in the top and the bottom. So all we got to do is divide the imaginary 1 divided by this imaginary 1. So my horizontal asymptote is 1 over 1, which is 1. Now let's solve for x-intercepts. X-intercepts, according to the notes, set y equal to 0, which is your f of x, and then solve. So let me go ahead and just erase some of this stuff here. Okay, so I'm going to set y equal to 0, so 0 equals x squared plus x minus 6 all over x squared minus 4. Now, it's kind of hard to solve an equation when you have a denominator, so let's eliminate the denominator. I want to get rid of the bottom by multiplying both sides by the bottom. Because look what happens. If I have this number divided by this number, these two cancel. What is 0 times anything? 0. And then anytime you have a quadratic, you want to factor the quadratic. So to factor a quadratic like this, what are two numbers that multiply that give me -6, but when I add them gives me a +1, because this is an imaginary 1 right here. Okay, so you start thinking 2 and 3, but one of them has to be negative because this is a -6, and then the middle term is a positive. So anytime you have a middle term positive, then the bigger number has to be positive, the smaller number has to be negative. So -2 times a 3, -2 plus a 3, they give me my two answers. So really my factors are x minus 2, x plus 3 equals 0, and then I can solve my x-intercept. X is equal to 2 and -3. Okay, and then for the y-intercept, I hope that you're writing the notes, because I'm going to go ahead and erase domain here. For the y-intercept, it's very easy. Let me find my pen. So it's y-intercept. So for the y-intercept, all I got to do, if I go back to my notes, is set x equal to 0 and then just solve. So for every x, I'm going to plug in a 0. So it's going to be 0 squared plus 0 minus 6 all over 0 squared minus 4. Really, your y-intercept is always going to be just the numbers without the x being divided. So -6 over -4 is 6 over 4, which is 3 halves. So this is my y-intercept. So let me go ahead and go back to x-intercept, because I don't know how your professor wants it. Your x-intercept answers are always going to be 2, 0 and -3, 0. For your y-intercept answers, they should always be the opposite. It should be 0, 3 halves, because those are your y-intercepts and your x-intercepts. So if your professor wants it in point form, then there it is. If he wants it in just a y form or x form, then there they are. Next problem. Okay, now that I've showed you step by step how to do the first one, I'm going to go a little bit more quicker to solve the second one and the rest. Okay, let me go ahead and do another video, and we'll start off with B.